Suppose that x1, x2 up to xn are jointly distributed random variables. Then if I stack them one above another, then I get a vector. This vector is a member of Rn. It is n cross 1. This being composed of random variable components is called a random vector, which I have denoted by x. So a random vector is nothing but a bunch of jointly distributed random variables. Now we are going to discuss how to define expectation and dispersion or variance of a random vector. The expectation of a random vector x is defined as another vector of the same size where I have taken expectation component by component. Since these are just random variables, so I already know how to take expectation of each component. I just stack them together and I get expectation of x. If even at least one of them fails to exist, I will say expected value of the vector x fails to exist. Next, we shall define the variance of x. This is going to be a matrix, an n by n matrix. N is the dimension of my random vector x. The diagonal entries, there are n diagonal entries, are nothing but variances of this xi's. The off-diagonal entries will give you the covariances. For example, this off-diagonal entry will be covariance between x1 and x2. Similarly, this off-diagonal entry will be covariance between x2 and x1. Now, since the order here does not matter, so this covariance is actually equal to that covariance. And in general, if you consider the ijth entry, the entry in ith row and jth column, then it is covariance of xi and xj. And as I said already, even if I swap this order, it will not change. So this matrix is a real symmetric matrix. In this problem, I am going to give you a random vector of 3 components. The first component is binomial 10, 1/3. The second is obtained from the first as 10 minus x1. x3 is always equal to 5, so it is degenerate at 5. Your job is to find out expectation of x and the variance matrix of x. In case you have forgotten, I will quickly remind you about the expectation and variance of the binomial distribution. For binomial NP, the expectation is this and the variance is this.